Hello and welcome to our webinar today on supply chain for engineers. A quick introduction for who we are and what we do here. PHYTEC is a manufacturer of embedded SOMs, which are embedded computing modules that allow for rapid prototyping, part management, and design reuse. My name is Christian Brown. I'm a hardware design engineer here at PHYTEC. Today, my partner for this webinar is the Global Supply Chain Manager here at PHYTEC, Alyosha Simon. Alyosha, do you want to give us a little overview of who you are?
Hello, everyone. I'm Netw Simon. I'm responsible for the supply chain or the global supply chain for PHYTEC America and PHYTEC globally at some point. And we would like to walk you today through the supply chain overview in general about the current market, which we are in right now. And we also prepared some tips for the future.
Yeah, and we know that we have a lot of students who are on this webinar. We have a lot of engineers, a lot of manufacturers, and we want to make sure that we address any issues. So if you have any questions throughout the entire webinar, please do submit those to the Q&A as soon as you have them. You don't have to wait till the end, and we will answer at the end as many of the questions as we can. We will also make the slides and notes from this webinar available after the webinar for anyone who needs them. So we're going to get started. Alyosha, you said you're in charge of supply chain. For those who aren't familiar, what is supply chain? How does all of that come together? What do you do?
So supply chain is basically the complete process from having the raw materials until have your finished product in your hands. So materials.
Hold on, real quick. I'm an engineer. I'm a design engineer. I just take chips and parts and put them into a design to make those circuits that work and create the final product. You're talking all the way back from when we mine the materials out of the earth all the way up through when I get it and then beyond when it goes to the customer, right?
Basically, yes. Just think about, wouldn't it be awesome if parts just appear automatically and there's no process before it and you can just grab it and design your SOM?
That's how it works. I go online to a distributor like DigiKey or other distributors and I order the parts and they show up.
That would be ideal, but unfortunately that's not the case. So for that, there's a whole process to get parts to distributors. So we are talking copper and sand and tantalum. So basically raw material like earth, we then turn at foundries into semiconductors or at PCB manufacturers into PCBs. The foundries basically have the wafers and they produce out of those wafers, they produce the semiconductors.
So how long, obviously there's some time to mining the materials and shipping them, but once those materials show up at the foundries, how long does it typically take for things to get made?
So at the foundry, we are talking about physics, and basically it really takes like up to 26 to 30 weeks to have the first semiconductor ready to be packaged and shipped out. So it is quite a process, and it takes time, it takes energy to make chips out of raw materials. So once we are at the foundry and we have it shipped to the suppliers and distribution channels, there it will be basically processed and it will then be routed through the manufacturing facilities. At the manufacturing facilities, then we are moving forward and basically using the design you made. And basically there's the step where you think parts appear, then this already kicks in. So basically until you are there, 30 plus weeks are already done until we as a SOM manufacturer can use those parts to build our SOM to then ship it to you as a customer.
And for that part, we get parts in and that takes, like you said, 26 to 30 weeks for those parts to get made and sent to us. And then it takes whatever time it takes for us to run those through manufacturing lines, put all the parts on the board, solder them all down and get those parts tested and then shipped off to customers.
Exactly. So basically once we receive the parts, we then need to put them on our SOM or on the PCB, produce it, test it, and ship it to our customers, which could add another 4 to 10 weeks depending on the design and the complexity, and also if there occur any issues along the road.
And this is presuming that everything goes ideally. Materials show up at the foundries get things perfectly made through, no errors, send them off to the suppliers, they send them to us, we build the parts and we ship them to customers, and we're still talking 30 to 40 weeks of time for those parts to arrive.
In an ideal world.
And that assumes that nothing breaks down. If any part of this breaks down, the whole chain breaks down, right?
That's correct. So basically, if anything breaks down along the process, the timeline will be longer.
Okay, so what is supply chain's role in this? How do you help make this process work?
So my job basically here is to completely manage the logistics from A to Z, and also work with the manufacturing channels and with our manufacturers, with our contract manufacturers, with our in-house manufacturer, with also the semiconductor manufacturers to shorten the process, or actually figure out if there are any issues along the process to really produce our product in time to then ship it to our customers.
All right, so we see some pictures of you here in your various roles at PHYTEC as the global supply chain manager, at fabs, at silicon vendors, here in the office, at our production, in-house production. Can you give us what do you do as the global supply chain manager?
So as I said, I coordinate the global production at our in-house manufacturing as well as at our CMs in China and in the US. And I try to ensure the supply chain continuity from early product introduction or the NPI phase until EOL, the end of life of a product. We at PHYTEC try to not EOL products if we can secure our parts, or even by using second sources or alternative parts to make the product as long available as possible to have our customers' lives as easy as possible. We do that, or to be able to do that, there is a proactive communication which needs to happen with our sales department, with manufacturing, with engineering, to really solve any upcoming issues quickly. Because as I said, the ideal world is already 40 weeks. So if there are some issue along the road, it will add up to that. So we really try to be on top of everything, even implement second sources throughout the process to maintain our schedule and also keep the budget at some point in place.
So this is all what you do to try and keep things running in an ideal world where nothing goes wrong. Can you enlighten us? So let's talk about the elephant in the room. What's the current situation globally?
That's a good question. So we had a meeting to prepare that webinar, and the quote you see here is basically what I said about the current market conditions. So it is really something I have not seen before. I've seen 40-week, 60-week lead times. We are used to fluctuating lead times from 20 to 50 weeks at some point. We also had an allocation, but right now where the manufacturer is telling us they are with the back against the wall and they cannot ship and they don't know when they really are able to catch up, I've not seen that before.
So hold on, you said allocation market. Normally, like I said earlier, normally I go on DigiKey, I order my parts, they show up. Allocation is, this is beyond lead time. Lead time is like, oh, it's going to take a while, but then the parts will show up. What's allocation?
So allocation, if you go on DigiKey at some point or to a distributor right now and ask for a specific part, they probably don't have it. So this means that the manufacturer and also the distribution channels allocate to their customers when they will get their parts. So it is beyond lead time. So you can get something right now because you were the first who ordered like 2 years ago, or you're basically waiting for your parts 2 years. So, and this is all caused by a severe raw material shortage. And also there are in the market changes all the time. So manufacturers discontinue their chips to make room for new technology to move forward, to be cheaper and more efficient within their production. So it is a very, very severe problem right now.
So basically, right now we're facing unprecedented situations with supply, with demand. All of this is coming together. And then obviously some stuff has been happening in the past year or two.
If you think about it, just working from home, there was always like a push to have more working from home capabilities. But since COVID hit, like the whole world moved from an office setup to a work from home setup. And this work from home setup needs to be supported by new computers, new equipment, and all of those use electronic parts.
You're talking
correct?
Not just like people buying new consumer products that they need to work from home, new mice, new laptops, all of that, but also the back end network companies having to upgrade facilities and implement new product there as well.
Exactly. I mean, we are on a Zoom webinar, right? And the Zoom webinar is using server storage and cloud storage to process all that. And this all is basically using electronic parts. So basically, all of the demand on the market just increased drastically. And then there's always like discrepancies within the supply chain. So from a demand perspective, the demand just increased drastically, as I said, and will continue to increase because everybody is using smart devices, smartphone, smart watch, smart home, smart whatever, and all of those are powered by small chips. Thinking about cars back in the day, or not that back, but like in the 2000s, cars had just like a minimum amount of electronics, and now we are moving from horsepower, basically put a horse in front of your car and get somewhere, to chip power where you have autonomous driving, so the car gets you somewhere.
And these are all these smart systems that we're including: the smarter audio system in your car, smarter driving control system, smarter interaction with the people. All of that requires more computers.
It basically also goes to traffic sign recognition. So basically that your car tells you how fast you should go. Do you like it?
We all want the safest, newest car that has all the new gizmos and gadgets.
Exactly. I mean, if you like it or not, but the car now tells you to go 40 or to go 35 rather than you're in charge of it. So all of that on the demand side is basically increasing drastically and will continue to increase because it all becomes smarter. And
so you're seeing this crazy exponential growth between working from home, between devices requiring smarter implements. All of this is building up so that it's not just a linear, oh, we have more people, so we need more computers. It's just everything needs to be a computer now when we have exponential growth.
Exactly. So this growth is exponential. And then on the supply side, we cannot keep up. So the demand is spiking drastically, but factories to be set up to work at full capacity and to be efficient takes up to 3 years to really go to that stage. So you really want to think about that. The whole 30 weeks lead time I mentioned earlier, it is at a full capacity and a factory who is very operating very efficient. But you also need to get to that point, and to ramp up a new facility, it just takes time. And then you also have like a lot of small companies combined together to be more efficient, but this also at some point will result in having less manufacturers out there or less manufacturing facilities to keep up with the demand. So it is really an issue right now with supply and demand.
So just to clarify something you said about they're operating at full capacity, these manufacturing fabs, when they spin up a new building, when they have a new manufacturing place, they don't, just use half of it. They're all out. If they build a new place, they're building it at full capacity. And there's really no way when we say, hey, last week we wanted 5,000 chips, next week we want 6,000. That's not something you can just go, oh, well, we'll just work the machines harder because the machines are just going all the time.
Exactly. They are working 24/7, all day, every day. And then if something along the supply chain is disrupted by like a snowstorm or a power outage or a water shortage, which we experienced, then the whole supply chain or everything which is in progress at that time is basically gone. So you basically need to start from scratch again, and you have again those 26 to 30 weeks to really get your initial chips out. So it's also a huge investment to move forward. And as I said, supply and demand, and then we also have unpredictable disasters which just occur, like the power outages, snowstorms, and whatever happens. And it would be naive to say that in the future our crisis will become less dramatic. So as we all know, we all grow further together, everything is connected, and just a single piece of the puzzle can disrupt the whole supply chain, which is basically why we are in right now. And we need to be set up in the right way for the future to set us up that there's less potential to disrupt our supply chain.
So obviously there are other issues that happen, like with COVID. If you have almost all of the world's fabrication for packaging chips taking place in one small area and that country gets shut down due to COVID, all of a sudden the world has no chips.
The whole world doesn't get chips. And this basically becomes a huge issue, which is also why a lot of countries right now investing in infrastructure to build chips, because chips are becoming super important in our society, in our environment, and our economy right now.
Well, and you were saying earlier on the supply side, you talked about the process is continuous. It needs to go from one end to the other. And when these factories get shut down, like earlier where we had the factories in Texas that were shut down, the fabs that were shut down due to the cold storm that came down there, they were shut down for a couple weeks. Does that mean they lose a couple weeks of production, or what does that result in?
I wish, but basically think about there's like a clean room. So you have to, once you shut down the facility and you ramp it again, you have to reestablish the clean room. So basically you not only lose the 2 weeks or 3 weeks of the shutdown, you lose more likely up to 20 weeks to really get the process going early on again. Of course, there are shutdowns which are planned and which have slightly less impact, but it is not always the case. So, and as I said, all the gears need to work together to have the optimal supply chain, which is the 30 weeks.
And all that product that was on the floor when you had to do an emergency shutdown, they can't just resume working on it. It's gone. So basically, the situation that happened in Texas, you have, like you were saying, 26 to 30 weeks of production that at various stages in that 26 to 30 week cycle, all of that's gone. You have the couple weeks of shutdown, then you have 20 weeks of ramping these back up and getting them established again, and then you're going to have 26 to 30 weeks additional for new product to start hitting the market.
Welcome to my world. Luckily, in Texas, there was the option that it was a planned shutdown, so not everything was gone, but it was not good. And basically, it did contribute to the overall market situation that we basically don't have parts.
All right, so we're dealing with the situation. Demand's going up exponentially. Supply is logarithmic. It can't keep up even with normal growth, but it really can't keep up with the crazy growth we're having. And then to top it off, we have all these natural disasters that have happened that have caused the supply to be lagging even further behind because a year's worth of parts gets wiped out due to one situation. What's the good news? What are there ways that we can try and prepare ourselves to best meet those shortages that are going to happen during our design cycle?
Yes, it's basically like a roller coaster. Every day are popping parts of the production, and there's always ways and room for improvement and to set us up for the future, to have second sources available, to have multiple options to navigate through the crisis.
So have you ever had this situation where you go design a part, you create your circuit, and then you send your bill of materials into supply chain and they go, why in the world did you choose to put this part down? That part's already obsolete and we need to redesign immediately. We're going to talk over, in general, but also given the current circumstances in the market, how you can design using your resources through supply chain and making smart decisions to make the future easier for yourself. So tip number 1 is to expand your network. If your company has a supply chain or a purchasing department, you should reach out and make a friend. They're not scary. They want to talk to you. They would rather have your help to make their job easier, and they would rather give you their help to make your job easier. You can utilize your teammates. A lot of the purchasing department here at PHYTEC has a background in engineering, a background in product management. They know what these parts are. They know some of the technical details, and they can understand if you have to explain some of those technical details to them. They have that infrastructure and contact, and you can make use of them to make your life easier. What if you don't have a supply chain or purchasing department, Alyosha?
Actually, there are also a couple of options. You can always reach out to your distributors. They have FAEs, field application engineers, who are there to help you, to bring you solutions. They're representative. There is like a whole network out there, like different distributors or manufacturers who can help you make decisions, and also reach out to your manufacturer like NXP or TI, which we are building most of our SOMs with, to make the decision, what shall I use? Also reach out to us, reach out to PHYTEC. We are designing SOMs, so we are aware of the market and we know what parts we should use and which part we shouldn't use moving forward to have an idea what is good in the future.
That brings up another good point there, which is if I need to get in contact with a manufacturer to find out more detail or information about a part, oftentimes if I just directly email them, they're going to ignore that. I'm certain with the current situation in supply chain, they're getting bombarded with emails all the time.
So basically use your network, use your supply chain people to reach out, because usually they are working with them on a day-to-day basis. So reach out to them, get more insight here, and really use your network and also grow your network. There are probably local manufacturers around the corner which are building embedded devices. So just use them, connect with them, build your network.
All right, so tip number 1, expand your network and use your network. Tip number 2, which we put here in the second spot, because when you design a part, you should always try and find second sources at least. Ideally, we try and find second sources, third sources, and fourth sources for every part that we can when we make a design. You want to keep your options open. You want to design smart so that you can second source your parts, because in the current market, it's not a matter of if your parts will eventually become hard to find or out of time to find them. It's a matter of when.
Exactly. So we have a couple of options, or like a small checklist here, which Christian will run you through.
Yeah, there are a couple things you want to check off when you're second sourcing to make sure they match up. You want to make sure your pinout matches. You want to make sure that your package size matches so you don't have manufacturing issues. You want to make sure that your operating and maximum conditions match. You want to make sure that all your electrical characteristics between designs match as best as possible. And you want to make sure when you go to reflow that your reflow profile matches. Here at PHYTEC, we use a vapor phase, which allows us a much broader range and a lower max temperature. But most contract manufacturers that you work with are going to use reflow ovens in a standard reflow profile, and you need to make sure new parts don't exceed that. And finally, availability. And this goes back to reaching out to your supply chain, reaching out to your manufacturers, and finding out there's no point in second sourcing a part only to find out that you also can't get your second source. So you want to make sure that that second source part is available. Reach out to supply chain and make sure that they say this part's a good part to select, and reach out to your manufacturers and use external tools to find out that that part will be available in the future.
So as you see, those are quite a lot of steps you need to take, but don't be scared. There's help out there. There are external tools which help you to make decisions. You can always reach out to distribution channels, through manufacturer websites, to your supply chain team, who again has the network again, or tries to, or is in touch with the manufacturers to really make sure that your life is as easy as possible.
There's also a range of results you can find when you go to second source parts. Ideal is you find a part that matches your part exactly and doesn't impact form, fit, or function in any way. Between that, you have some parts that may match the form and may manufacture down well, but impact functionality or require software adjustments. And finally, in a worst case scenario, if you've done a poor job of selecting a part or just have bad luck, you might end up in a spot where a respin is the only available option.
So this is, again, a lot of steps. What did we do at PHYTEC to improve the situation, or what are our examples here to make the best possible to be prepared for the future?
So yeah, you hear all of that second source stuff. That sounds like a lot of stuff to check. That sounds like a lot of work to do. And trust me, it is. But why should I do more work now to make sure that, those parts are second sourceable? To help out me in the future. We have some examples here, some stories from our customers and from our engineers here at PHYTEC that have faced some problems in their design and with second sourcing that reaching out to supply chain or making smarter decisions could have helped with. So the first example we're going to talk about is the clock that ran out of time. Say you design it down a Wi-Fi circuit, you have to pick a slow clock, you pick an oscillator from your library and create your circuit based on a trusted reference design. After you've made that, tested it, and verified it, all your other engineers at the company, anytime they want to put down a Wi-Fi circuit, just copy your design and put it into their system, sometimes years down the line later. And then finally, eventually that part becomes EOL. Now you'll notice that part's kind of unique. It's a 12-pin oscillator, which at the time was common, but now, years later, is almost unheard of. There's just no second sourcing, and you're now in a spot where every board that uses that part needs to be respinned.
So as a takeaway here, components go out of style like fashion. It changes. And also don't use copy paste all the time. I mean, copy paste is very powerful and can help you a lot, save a lot of work. But even if you proceed with copy an old design over, just check up real quick, does it still comply to the current market conditions? And also, are the parts still in a phase of their life where they should be still considered? So really make sure, even if you use something from like an earlier design, if it's still accurate, if you can still use it.
And that's another situation where you can reach out and make use of your purchasing team, your supply chain, because as an engineer, I may not be up to date on what phase of life that part's in or whether or not it's still the current style or the upcoming style, but you're aware of those market trends and you can help me find that information.
And I'm happy to help.
So a second example is the MELF resistor, known as the metal electrode leadless face, or as manufacturing likes to call it, most end up lying on the floor.
Which is based on the reason that it's a round shape of resistor. And basically what happens if you put something round on a flat surface, it rolls away. So from a design for manufacturing standpoint, you really don't want to do that.
Sometimes you need to use a part with unique attributes because you have specific requirements. But in general, if possible, you should avoid anything that has a unique footprint, a unique pinout, a unique attribute, or really anything unique about it, because that typically just makes it harder to source, more expensive, and harder to manufacture.
So again, as takeaway, avoid anything unique and also check with your manufacturer for advice and design for manufacturing if the part you are collecting right now or designing to your new schematic does work in the field.
All right, so we've talked about reaching out, making sure to choose designs that are correct, and second, sourcing, designing parts that are not unique. What happens if some part is unique and you need to use it in your design? Some parts can't be second sourced easily. We're talking about your processor, your PMIC, sometimes your PHYs, other parts on the board that can be hard to find a second source or straight up impossible to find a second source for. We have a couple clever solutions that you can add into your design to help find options for getting around those supply constraints. Option number one, you can create a dual footprint that allows for multiple parts to be put down that meet the same need. Here you see in the design the options for JTAG connectors, where we have one surface mount JTAG connector that is also connected to the same signals as a through-hole mount JTAG connector. In this situation for this product, if we were unable to source one of those two parts, we would still be able to continue producing product that people could connect to through JTAG and continue to make use of that product, even with supply constraints. You need to be careful when you do that because the signal quality can be impacted by having stubs off of the one connector to another. You want to make sure that you keep those signals clean as possible and be extra careful in layout when you have to do that solution. Another opportunity is to make use of space on the board by creating a dual footprint option to populate with different options depending upon availability and customer need. You see here in a design, we have an option where you can populate either NAND or eMMC depending upon the customer desire. In a situation where both are available, the customer can choose based upon their needs for their solution. But in a situation where one becomes unavailable, you could choose to sell them a part that has the other population option populated. Obviously, a change between NAND and eMMC is going to require some software updates, but it at least presents a solution that you can move forward on. Versus if you only had one of those footprints down and you could not supply it, your customer simply just can't get product.
So basically, every option you do now prevents you from a possible line down situation in the future, which is always what you would like to achieve to really keep your production running as long as possible.
Finally, when you're making designs, you want to add in design options that allow you to make decisions in the future that can allow you to populate multiple options. We know that space is always a constrained resource when it comes to PCB design, but sometimes making smart decisions can help you in the future. For instance, we have this USB transceiver here, where there are two parts that are available. One of them was supply constrained, one of them was not. And electrically, physically, and every other way, they matched, except for the strapping conditions on boot up in the mode that we wanted to use. For one of the parts, it required the strapping to be pulled to power. For the other, it required it to be pulled to ground. And for that purpose, we couldn't use it. A way you could get around that is to implement a selectable population that allows you to either pull it to ground or power, which would allow you to use either chip in the solution using just a BOM change.
So as main takeaway here, make smart decisions right now, to have flexible options on your BOM and your PCB in the future to really avoid any line down situation along the road.
So tip 1 was to make use of your resources, expand your network, and make use of those people in your company. Tip 2 is to make wise decisions in allowing for second sourcing and always having at least a second source or a second source option if possible. Tip 3 is to act early.
So acting early means share your thoughts and your BOM basically as early as possible. Once you have a rough design or rough specification, just spread it out to your supply chain team so that they can have a look and basically give you feedback on, are you using the most reasonable parts?
So I know as an engineer, a lot of the times we like to design our circuit, get our stuff all together, create our BOM, and then present it to supply chain and say, here, we didn't want to burden you with extra work. Is there a point at which it's too early to involve supply chain?
In my opinion, there's not. So the point is that the earlier you involve them, the better. Of course, they can always tell you, right now, I'm sorry, I'm busy, but then that's on them and it's their choice to tell you, I cannot right now, but at least they have the option. And also just getting back to the example of the oscillator, it's a 12-pin design. So this would be something we can easily see by just looking through the BOM that this is not an optimal part anymore because it has no second sources, because we did move to like a 4-pin or even 2-pin. So just
and that's a recommendation that if I were to bring that to you when I was specifying, you could come back and say, hey, that's not a current design. You want to switch that out. I mean, there are plenty of other oscillators we could substitute in there that are current designs and would have saved us from the situation. But if I don't present that until the board's fully designed and ordered, there's nothing more we can do.
Exactly. So just be early, be ready to get feedback and also accept feedback, as well as start the conversation early, because there's also the option that some of your colleagues you haven't even talked to had a similar issue you're not aware of, and supply chain could easily point that out to make everybody just happy.
So as long as I communicate clearly to you what stage this BOM is in, whether or not it's in specification, whether or not it's in design, whether or not we're at the end and this is the final BOM that you need to get final approval for, you'd rather have the BOM, and if you have time, be able to review it and help me out. And if you don't have time, then you don't have time, versus if I don't send that BOM to you early, even if you had time, you can't help me.
Correct. So basically share the BOM, share your thoughts, and just work on that together as a team to get a good solution for all of the departments.
All right, so wrapping up, the 3 tips we have for helping avoid and plan for when these situations come up: expand your network, and that's reaching out to supply chain, reaching out to manufacturers, reaching out to FAEs, and making use of those connections to find information and to find out what parts, where the market trend is going. Tip number 2 is find second, third, and fourth sources if possible. Keep your options open, design smart, second source. And the more work you do now to prep yourself for that, the less work that you and your supply chain friends will have to do in the future when you run into those problems. And finally, act early. Talk to your supply chain as soon as possible when you're looking at spec. Have them help you out with component sourcing, making wise decisions in part selection, and work in parallel. And like Alyosha said, sometimes you're facing a problem that another engineer has already done and you don't know it, but since they had to help that person, or they had to see the after effects of not getting to help that person, they can give you advice about how to avoid those problems as well.
And tip 4, basically partner with PHYTEC. We can help you move your design faster by just using a SOM rather than a chip down, because a SOM is one part to monitor rather than a whole BOM, which could be up to 200 parts. We as PHYTEC do custom carrier boards and design services. So we are also working along the network and also know what parts we design in. We do the lifecycle management. So you don't really have to care about the SOM you design in, because we will help you a lot and also speed up your design. So we can basically help you to offload work and make decisions smarter and faster.
All right. So hopefully we were able to help you out with getting to know what supply chain is and some tips and tricks you can do to make your life easier when it comes to working with supply chain and to making wise decisions. We're going to have some time now for some questions and answers that came in during the webinar. If you have any questions you just thought of now, continue submitting those. We will try to get to as many of those live here during the webinar, and we'll also follow up on those after the webinar for any we can't get to now.
So please let us know all your concerns, questions. We are happy to help.